Hey everyone, welcome back to another session of carbon and its compound. In the previous session, we have already understood a little bit about carbon, its allotropes, organic compounds and hydrocarbons. We have also understood in details about alkane, alkenes and alkynes. In today's session, we are going to move ahead in the chapter and I will start with functional group. Later on, I'll also start nomenclature. Nomenclature is a very important topic in terms of class 10th. But before I start my session, I would like to request you all to kindly subscribe my channel. So let's begin today's session. Now, first of all, we will try to understand what is a functional group. Now, a functional group is an atom itself, or it can be a group of atoms present in a molecule which largely determines its chemical properties. That is, the atom or the group of atom will give some new properties to this compound to which they are being added. Okay, so let us take an example. Let us take example of ethane. In our previous session, we have already understood that it is a kind of alkane, that is, there is a presence of single bond between carbon and carbon. Okay, so and the prefix which is here eth means 2 carbon compound and ane is telling that it is alkane. Okay, so it will be like this, 2 carbon containing compound from eth and it is alkane, so single bond between the carbon atoms. Now you know that around carbon there should be 4 bonds, so for this carbon 1, 2, 3 and this is the 4th bond. For this carbon this is 1 bond here, this is another bond with H, this is another bond with H. So this is the structure of ethane. Now if in this ethane by any chemical reaction, if you will try to replace this H with OH, replace this H with OH. So what will be the new? Now this much will remain same, this side will also remain same. H here, H here, H here, this side H here, H here, but in place of this H you will put OH. Now it will change to something new. This is ethane here, right? But this is not ethane, this is something new now. Okay, now it is just like we are adding a spice. See, every spice has got its own taste. For example, if you are adding too much of chili, okay, so the taste will be, it is very chili, you can say, na? It is very spicy now. Okay, now if you are adding too much of the salt, what will happen? The taste will change to too much salty. If you will add too much of sugar, the material will change too much sugary in taste, right? So similarly, whenever a new atom or a group of atom is added in a molecule like this here, so this new group of atom or atom will impart, or it will give, or it will add some new properties. Okay, and the newly added thing, this added thing is called as a functional group, is called as a functional group basically. Okay, so this is the understanding for a functional group. And now how can we say that it is giving a new chemical property? Now this part of the definition. Now see, ethane is a gas in general and this newly formed compound is called as ethanol. It is a kind of alcohol, so it is liquid in nature. So you can see that the gas is changing to liquid. Gas is changing to liquid just by replacing H with OH. So this is how it can change the chemical property of a given molecule or a compound, like here it is ethane. Okay, so let us see some examples according to your course. In your course, the functional group can be a halogen. If there is an halogen, you will see a symbol like Cl along with the carbon chain. This dash or this line is showing that this is attached to the carbon chain. You can see bromine symbol Br, this is chlorine Cl. You can also see I, that is iodine. You can also see F, that is fluoro. Okay, right. So this is the identification of the halogen group. Whenever halogens are there, they are always prefixed to the compound like chloro, bromo, iodo, and so on. We will see its example later on. If there is an alcohol, then to the carbon chain, this dash or the bond is showing the attachment to the carbon chain, and you will see OH. If you are seeing OH, it means that the given compound is alcohol. Okay, if it is aldehyde, you will see that this is the bond with the carbon, CH double bond O. This is the symbol for aldehyde. If you are seeing that the symbol is like this, C double bond O, and other side it is the bond which is attached to the carbon chain, then this is a ketone functional group. If you are identifying a carboxylic acid, then you will have to see that the C is attached, one side it is double bond O, other side it is OH. Okay, so this is its symbol, and this is the alkene. You are already knowing that there will be a presence of double bond, and if it is an alkyne, there will be a presence of triple bond. Okay, so let's move to our next topic about the homologous series. Now, what is a homologous series? As the name is telling that it is a series. So it is a series of compound having the same functional group, and obviously if the functional group is same, it will show you similar chemical properties, and the successive member of which differ by a CH2 unit. Okay, it is very easy to understand. If, for example, if you will take an example of alkane, let us say, which we have discussed in our previous session, you can check the slide there also. Alkane starts with methane, right? That is, it is CH4. After methane, we are having ethane. Okay, it is C2H6. After this, we are having carbon 3, 1, 2, 3, and it is C3H8, that is propane. After this, we are having butane. Okay, so you are seeing that every member is increased by CH2. It is CH4, C plus C, C2, 4 plus 2, 6. Now 6 to 8, again there is a gap of CH2. C3H8, C4H10, again there is a gap of CH2. Okay, so it is a series of compounds. So you have seen the homologous series of alkane. You have also seen the homologous series of alkenes in my previous session. You have also seen the homologous series of alkynes. So you can see, or you can make yourself the homologous series of any functional group, be it is an alcohol. For example, if it is alcohol, it will start with CH3 OH, that is, it is methanol with one carbon, then there will be C2H5 OH, then it is ethanol. So again there is a gap of CH2, you can see. Okay, there is a gap of CH2 between this part. I am talking about this part. The functional group remains the same, alcohol. So this is a series of alcohol, homologous series. Okay, so homologous series is what? It is a series, simply a line from 1 to 10, you can say, which is having the same functional group. And if the functional group is same, you know that it will have the same chemical property. If it is alcohol, it will remain alcohol, that is OH. Okay, and each successive member, that is the next new member, will differ by CH2 unit or by CH2 group, right? So what are the characteristics of homologous series? This question is usually asked in the board exam also, that list the characteristic properties of homologous series. They are very easy. All the members of a homologous series can be represented by a general formula. For example, if I will talk about alkanes, alkanes have got a general formula of CnH2n plus 2, right? Similarly, you can write for alkenes. Okay, CnH2n. You can also write for alkynes. It is CnH2n minus 2, right? The molecular formula of any two successive member of a homologous series differ by a CH2 group. I have shown you here. The molecular masses of any two successive member of a homologous series differ by 14U. That is, there is a difference of 14U. Now see here. Now beta, the molecular mass is calculated by adding the mass of individual atom, right? Now if let us say CH4 has got X molecular mass, let us say, okay, I am not calculating, although it is very easy. Okay, this is if its value is X, then this X will get increased by CH2 unit, right? Carbon has got mass of 12, hydrogen has got 1 and it is 2 in number here. So it will come as 14U. So in this molecular mass we will have to add only 14U and you will get the molecular mass of C2H6, right? Similarly in C2H6 you will add 14U, you will get the molecular mass of C3H8. Okay, so it differs by 14U or CH2 group, that is, this is the 14U actually. Then fourth one, all the members of a homologous series have the same functional group. Okay, right? If we are talking about alkanes, we are talking about single bond between carbon and carbon. If you are talking about alkenes, you are talking about double bond between carbon-carbon atom. If you are talking about alkynes, homologous series, you will see triple bond between carbon and carbon. If you are talking about alcohol, you will see that OH group, okay, will have the same functional group. All the members of a given homologous series show similar chemical properties. It is right. Why? Because if it is a double bond compound, it will show the double bond compound properties. If it is a triple bond, it will show triple bond. If it is an alcohol, it will show OH. If it is a halogen like chlorine, bromine, iodine, it will show its own. Okay. So now let's move ahead. Now we'll start with nomenclature. Nomenclature is what, beta? Nomenclature in a very simple language is naming. Now we are doing carbon, so we are also saying that naming of organic compounds. It is a very easy topic, at least up to the class 10th. Okay. So you will have to keep in mind certain points. Now first of all, who decides how to give the names? It is decided by International Union of Pure and Applied Chemistry, which is in short also called as IUPAC naming. Okay, so the rules are set by them and we are following the rules. So you will have to identify firstly the number of the carbon atoms in the given compound or in the given molecule. We will I will show you some examples, there you will be able to understand in a more clear way. Second, select the possible carbon chain, longest possible carbon chain. You will have to select the longest possible carbon chain, okay, containing the functional group. Either it should have the functional group, it can have a double bond or a triple bond or alkyl groups. Now what is an alkyl group? Alkyl groups right now you can understand like CH3, okay, it is also called as methyl. They are usually present as a side chain, okay, or you can say it is C2H5, it is called as ethyl. The functional group present in the organic compound is indicated either by a prefix or a suffix. So for the identification, like when you are choosing the longest possible chain having a functional group, then when you are naming a compound, you will give either a prefix or a suffix for those functional groups. I'll discuss example, there you will be able to understand. If a suffix is added, that is the half part of the name, that is the later half part of the name or the last part of the name, then you will have to add. If a suffix is to be added, the final E from the name of the carbon chain is deleted. Like if it is an alkane, so the E will be going. If it is an alkene, then last E will be not there and we will add the suffix decided for that functional group there. When we are doing examples, there you will again able to understand in detail. And then you will have to give lowest possible numerical prefix. That is 1, 2, 3, lowest number you will have to give to a functional group while naming a compound. Now let us start with some examples. So first we are discussing about alkenes. Now you know that how to identify alkene or a functional group. If you are seeing the presence of the double bond, then it is alkene. And if it is an alkene, then you will have to give a suffix ene. Okay, although some of the examples we have already done in our previous section, where I have explained you the alkane, alkenes and alkynes. Now here you are seeing that it is having only 2 carbons, like 1 and 2. You will have to give numbering. It is all in rough. Okay, so this carbon I am giving numbering 1, and to this carbon I am giving number 2. Now you can do numbering from the front also, 1, 2. Now in both the cases we are seeing that the double bond is coming with first carbon. With this first carbon the double bond is coming. Now with this carbon also the double bond is coming, right? So you can do either ways. Numbering is correct from either, you can take the numbering from this side to this side or from this side to this side. In both the condition, the first number carbon is getting the double chain. If we are going from this side, the first number is getting double bond. If we are going from this side, then also the double bond is coming with the first carbon. So either is correct. So now it has got 2 carbon. So the root word, you know that for the carbon we are having the root words. For 1 carbon we are always writing meth. For 2 carbon, eth. For 3 carbon we write prop. For 4 carbon we write bute. For 5th carbon we write pent. In our previous session we have already done this. For 6 carbon we write hex. For 7 carbon we write hept. For 8 carbon we write oct. For 9 carbon we write nan, and for 10 we write dec. Okay, so here the total number of carbon are 2, so we will write eth. Okay, now with 1 carbon we are attaching the double bond, so ene. Generally 1 is not shown, so it can be named as simply as ethene. Okay, with 1 carbon the first bond is coming, so we are writing the position of the double bond here. Okay, although number 1 is never mentioned as such, or the prefix 1 is never mentioned, so generally it is called as ethene. Now if you see this one, if we are doing numbering from this side, okay, then this is first carbon, this is second carbon, this is third carbon. If you are doing numbering from this side, then this is the first carbon, this is the second carbon, this is the third carbon, right? So when you are doing numbering from this side, from front to back, you are seeing that the double bond is coming with second carbon. This double bond is coming with second carbon. Now when you are doing numbering from back to front, the double bond is coming with first carbon, okay. So what IUPAC says that we will have to choose the longest possible carbon chain. So we are having this is the longest possible carbon chain. Second point says that the double bond or the functional group, they should have minimum possible numerical value. So we are going to take the backward counting from back to front, because in back to front counting this carbon or this double bond is coming with the first carbon, okay, and we are not going to do the numbering from front to back, because in front to back the double bond is coming with the second carbon, but from back to front it is coming with the first carbon. So total number of carbon atoms 1, 2, 3, so you are going to write prop for 3 carbon, okay, with 1 position the double bond is coming, so we are writing ene, or simply because we do not mention the 1 as a prefix, we are going to write it as propene. Okay, now this one, if you are doing the backward counting, this is first carbon, this is second carbon, this is third carbon, this is fourth carbon. If you are doing the front numbering, this is the first carbon, this is the second carbon, this is the third carbon, this is the fourth carbon, right? Now the double bond is coming with the first carbon in backward counting. When you are doing the counting from the front, the double bond is coming with the third carbon. So obviously we are going to take with the backward counting. So total number of carbon atoms are 4. So we will write but 1-ene. Okay, because it is with the 1 carbon or the first carbon, the double bond is coming. And simply we will write butene. Now here in this one, if you are doing the backward counting, 1 carbon, 2 carbon, third carbon, fourth carbon. If you are doing the front to back counting, this is the first carbon, this is the second carbon, this is the third carbon, this is the fourth carbon. So the total number of the carbon are 4, right? Now we will have to choose the carbon where the double bond is getting the lowest possible number. Now here, when we are going from back to front with the second carbon, the double bond is coming, right? Now when we are doing the numbering from front to back, again with the second carbon, the double bond is coming. So it is your choice whether you want to take counting from front to back or from back to front, because in both the cases the double bond is with the second carbon. Okay, so it is your choice. So the position of the double bond is 2, so 2-ene, or simply you can write 2-butene. In front you are writing the position of the double bond, that is 2. Here 2-butene. Okay, now let us see example from the next alkyl, from alkynes basically. So you know that alkynes are the triple bond containing compound. So this is its identification, and if alkyne is there, you will have to write the suffix YNE. There is no prefix. Okay, so the rules are same. Here we are having the 2 carbon, this is carbon number 1, this is carbon number 2. If you are doing the backward counting, if you are doing the counting from front to back, then this is carbon number 1, this is carbon number 2, right? Now you are seeing that the double bond is coming with the first carbon in front to back counting, and when you are doing the counting from back to front, again the triple bond is coming with the first carbon. So it is your choice again. So for 2 carbon we are having eth word. Now the triple bond is with the first carbon, so you are going to write 1-YNE, that is its suffix. Now in short you can write it as ethyne. Okay, now in this case if you are doing the front counting, this is first carbon, this is second carbon, this is third carbon. When you are doing the backward counting, then this is the first carbon, this is the second carbon, this is the third carbon, right? So total number of the carbon are 3, and this is the longest one, so you can write prop. Now look for the position of the triple bond. Triple bond should get the lowest number. Now when you are doing the backward counting, the triple bond is coming with the first carbon. Okay, this carbon next to it is the triple bond. Okay, now when you are doing the counting from the first one, that is from front to back, you are seeing that the triple bond is coming with the second carbon. Okay, so obviously we are going to take the lowest one, so backward counting we will be taking, and with the first carbon the triple bond is coming, so 1-YNE, and it can be written as propyne in short. Okay, now here in this case if you are doing the backward numbering, this is the first carbon, this is the second carbon, this is the third carbon, this is the fourth carbon. If you are doing numbering from front to back, this is the first carbon, this is the second carbon, this is the third carbon, this is the fourth carbon. So in front to back numbering, we are seeing that the triple bond is coming with the third carbon, and when we are doing the numbering from back to front, we are seeing that the triple bond is coming with the first carbon, right? So we will write the total number of carbon are 4, so but, okay, and but 1 ine, okay, so in short butane. Now here in this case you are seeing that the total number of carbon are 4, so you can simply write but, okay. Now look for the position of the triple bond from back to front. This is the first carbon, this is second carbon, this is third carbon, this is fourth carbon. The position of the triple bond is with the second carbon. Now when you are doing from front to back, first carbon, second carbon, third carbon, fourth carbon. So here the position of the triple bond is with the second carbon. So in both the cases position is with second carbon, right? So it is your choice, either ways it is correct. So you can write but 2-yne, or in short we can also write it as 2-butane, okay. Now let us go to the other example. Now the other example is from haloalkanes. Haloalkane is also a functional group. How you can identify? Either there will be a presence of fluorine atom F, or chlorine atom Cl, or bromine atom Br, or iodine, that is I. If they are present, you will have to attach the prefix, that is in the beginning of the name you will have to attach, okay. So if it is F, that is fluorine is there, you will write fluoro. If it is chlorine, you will write chloro. If there is a bromine, you will write bromo. If there is I, you will write iodo, okay. Now we will be able to understand an example. Now in this example there is just one carbon, so beginning will be with meth, okay. Now it is a single bond, so it will be ane, methane, okay. Now position of Cl is obviously with one carbon, so it will be chloro, or you can write 1-chloromethane, that is also correct, okay. But there is no need of 1, you can simply write chloromethane. So it is a prefix, it will be added as a prefix. Now in this carbon, sorry, in this molecule you are seeing that there are 2 carbon, so eth. Now there is a single bond, so obviously it is ethane. Now this bromine is attached to which carbon, okay, you will have to write that. If you are doing numbering from front to back, then this is the first carbon, this is the second carbon, okay. Now if you are doing numbering from back to front, this is the first carbon, this is the second carbon. So we are going to take the numbering from the back side, because in the back side bromine is coming with the first carbon, okay. So we will have to give the lowest possible numerical number to the functional group. So Br is coming here with the first carbon, but when we are doing from front to back, it is coming with the second carbon. So obviously we are going to take the backward one, so it will be 1-bromo, prefix for Br is bromo, bromoethane, 1-bromoethane. I'll write neatly, or simply you can write bromoethane, okay. Now here there are 3 carbons, so it will be prop, okay. Everywhere you are seeing single bond, so it is a propane. Now identification of the functional group, this is I, so you will have to do backward and a front counting. When you are doing backward counting, this is the first carbon, this is the second carbon, this is the third carbon, right. Now when you are doing numbering from front to back, this is the first carbon, this is the second carbon, this is the third carbon. So you are seeing that in front to back counting, Iodo or iodine is coming with the third carbon, but when we are doing the backward numbering, iodo is coming with the first carbon. So we will have to give the lowest possible number. So we will take the backward counting and we will say it is 1 iodopropane. Okay, in this one I'll attach here Cl. Okay, so this is again a 3 carbon compound. So you are writing prop, everywhere there is a single bond. So you will write ane, propane. Okay, now you will have to give number to the carbon atoms if you are going from back to front. This is the first carbon, this is the second carbon, this is the third carbon. When you are going from front to back, this is the first carbon, this is the second carbon, this is the third carbon. In back to front, Cl is coming with the second carbon. When you are doing from front to back, again Cl is coming with the second carbon. So it is your choice that whether you want to take counting from back to front or front to back. Okay, in both the case it is coming at second position. So it will be 2-chloro. Remember, halogens are always prefix, that is in the beginning of the name. So it will be 2-chloropropane. Now this one 1, 2, 3, 4, it is having 4 carbon, everywhere you are seeing single bond, so it is butane. Now if you are doing backward numbering 1, 2, 3, 4, so with the first carbon Cl is there. Okay, now if you are doing from front to back 1, 2, 3, 4, so with the fourth carbon the Cl is coming. So obviously we are going to take this numbering. Okay, so it will become 1-chloro butane, right? Or you can simply say it as chlorobutane. Okay, both of them are correct because we never write position for the first one. So it will be chlorobutane. Now in this one, if you are going, like I'll attach here I, let us say. Okay, now this is a 4 carbon compound, so you can write bute. You are seeing single bond, so it will be butane simply. Now I is coming with this here. If you are doing numbering from back side 1, 2, 3, 4. So I is with the second carbon in the backward counting. Now if you are doing the counting from the front to back 1, 2, 3, 4. So I is coming with the third carbon. So obviously we are going to take the backward counting. So we are going to write here 2-iodobutane. Okay, so this is how we are giving the names to the organic compounds here. Okay, so I hope that in this session you are able to understand that how to name these compounds. And in our next session we are going to understand about the naming of alcohol, aldehydes, ketone and carboxylic acid. So if you are liking my sessions, do give them a thumbs up and kindly subscribe to my channel. Let's meet in our next session. Bye bye.